In the last lecture, we got through the beginnings of fusion and talked about stars undergoing the fusion process to create elements. Now let's talk about a little bit about those formation of those stars and concurrent formation of solar systems like our own. And again, this is the same idea we talked about before with those clumps of things. You get a big clump in the middle forming the star, and it starts to pull things in with it. There's a physics reason that it starts to spin, and that has to do with conservation of angular momentum. As it's spinning, it'll disk out. What I mean by that is it'll start to spin everything into a disk, kind of like spinning a pizza dough. And within that disk, you can get this mini version where you get little clumps forming and them starting to attract matter around them, and they're going to make their way into. Now we'll move on to what happens inside these newly forming planets. So right here you have just a uniform composition. It's just all the random stuff, the average of all the elements, any preformed minerals, anything like that exist. So it's just a ball of those minerals. But you have compaction and you have other stuff going on here. We'll talk later about the radioactivity and how it could be generating some of the heat down here, but certainly the compaction is generating some heat as well. So you've got now a hot ball of elements and minerals, and well, things that are more dense, they tend to sink towards the middle of that gravitational well, and things that are less dense are left in the outer part, and that's going to matter a lot for how our planet works out. And we're going to talk about these multiple concentric layers and the way the Earth differentiates. We're going to talk about differentiating the Earth into a couple of different things, and I just wanted to point this out because it can be confusing when you're looking at the stuff. There are at least two different labeling systems going on, and the first of these is to label things via their properties, what is acting as a rigid solid versus what is flowing. That's this physical properties part. We'll talk about that. Overlapping that, though, is differentiating by chemistry, and we'll talk about how there are certain minerals that tend to be in the crust and others that tend to be deeper. So I just want you to see ahead of time, and I'm going to point this out again in a chart in a little bit. So let's look here at a depiction of this layering that we're talking about. So we're going to break our discussion of the planet into these kinds of layers, and you have a lithosphere up top, followed by an asthenosphere. But remember these overlapping ideas. So we could also talk about the crust, which is part of the lithosphere here, followed by the mantle, followed by the core. At least the core is the same in both the ways of talking about it. Also want you to see the overall scale that we're talking about here, 6,400 kilometers. So I just measured that out on Google Earth, and we're talking about the distance from Dalton to the southern part of the Brazilian rainforest, or from Dalton to Scotland. So it is a long way to the center of the Earth. So we're talking about plenty of room and we can think of a simplest differentiation here of the core of the planet versus everything else. So we will talk about certain kinds of elements. Think about iron and related elements sinking towards the center, towards the core. They build up in the core, and then everything else is sort of left in the, what I'm on this slide calling not core, or more precisely mantle and crust of the planet. And here we have this sort of breakdown of these different layers. And I wanted to point out a few things. So first, see that there are bunches of layers, and now this is an older one. You can see that originally starts in 42. There are even more distinctions, and what you get is changes in the way earthquake waves or reflected seismic penetrations act in the layers and you get discontinuities, and so you get a bunch of layers depending on how many you want to make. We're not going to need to know all of these, but I just wanted you to see the different depth ranges. Also want to point out another thing on this slide. So you're going to see throughout the course that down here in the bottom right is, it's too tiny to see the text. It's a URL and you don't care to read a URL anyway. But if you ever want to go see where I'm getting a lot of these figures from, I'm citing them as best I can, and I hope that you will be able to, if you want to, go in and find these. Some of them are original scientific papers and go pretty deep. This is one. And you can get a lot more information for anything that you're interested in from some of these links. Now, this one is a hardcore peer-reviewed paper. Some of them are not so. Some of them will be websites with a lot to say about and maybe a better explanation than I gave you on. And here's that overlap again that we talked about. So you get the crust and mantle here, but then this lithosphere division is the crust and the uppermost mantle. But then you get this tiny little asthenosphere, and you would think, well, why bother to break that out? Well, it's going to be really important because of how it acts. It's going to do a lot of things to make plate tectonics work. And then, of course, below it you have the core, and you can differentiate the core into various parts. And later we'll talk about the